Hello and welcome. In this session, we're going to discuss about assembly language statement. So here you can see various assembly language statement. In this topic, we're going to cover executable instructions, assembler directives, and macros. So here is assembly language program consists of three types of statement. One is executable instructions or simple instructions. Another one is assembler directives or pseudo ops and macros. Executable instruction or instruction. The executable instructions are simply instruction tell the processor what to do. So these are the simple instruction tell the processor what system should do. Each instruction consists of operation code. Operation code is nothing but opcode and it is also called mnemonic. Each executable instruction generate one machine language instruction. Once it will be executed, then it will generate the machine language instruction, which is nothing but zeros and ones. Okay, which is nothing but zeros and ones. Here, operation code or opcode is add, or we can say this instruction as mnemonic. Okay, then here is two variables r1 and r2. Okay, so here we adding the content of r1 into the content of, sorry, we are adding content of r2 into the content of r1. Moving to next statement, which is assembler directives. This, in exam point of view, this is very important question. Okay, assembler directives or pseudo ops. The assembler directives or pseudo ops tell the assembler about the various aspects of assembly process. This thing is going to tell the assembler different aspects of a process, but this is not going to be executed. So it is called, these are non-executable and do not generate machine language instruction. Okay, it only shows the direction where the program is start and where to end. So assembler directive supplies data into the program and control the assembly process. It is work like control unit. Okay, we have studied in arithmetic and logic unit. Hmm. The control unit only control the instruction to arithmetic or logical unit based on the instruction, whether an instruction is logic or arithmetic. It defines by the control unit, but control unit not going to execute any instruction. Same the way assembler directives also maintain the control flow, but it not going to execute any instructions. Okay, so these are the tasks performed by assembler directives, like assemble code and data into specific section. Okay, then reserve space in memory for unutilized variables, control the appearance of listing, initialize memory, assemble conditional blocks, define global variables. So these are the function is done by assembler directives. Here we can see different example of assembler directives. So this is the start, end, origin, and equal. These are the four assembler directives. Here is the syntax for start: level, start, address. We can see program 1 start at address location, which is 1000. So program 1 is the level. Okay, then this program 1 going to start from this address location, which is 1000. Okay, so from this address location we're going to start our program. Then end is end of a program. Simply this end is end of a program. Then origin. Origin means usually the statement are executed in sequence manner. Okay, if a program is started from address location 1000, then it will be 1002, 1004, like this, isn't it? This is called in sequence manner. But you want to change the location, then you can specify origin 200. It means location counter, it means LC, which is nothing but location counter. Okay, location counter will set to address location 200. then the next execution is start from address location 200. Okay, so this location counter is going to store the next instruction which is to be executed. Okay, so it will going to store the address of the next instruction which is going to be executed. So this is the function of origin. Next is equal. This specify the symbol, and this is the equal is opcode and it is the address. So abc equal 1, it means the one, this one at anywhere in the code replace the abc. Okay, it replace abc with 1 at anywhere in the code. It does not reserve memory, it only replace value. Okay, it will not going to reserve any memory, it just replace the value which is 1. Okay, abc going to replace the value 1. Next is macros. So here we can see macros is a set of instruction and programmer cannot use it anywhere in the program by using its name. Okay, macro is a set of instruction and the programmer can use it anywhere in the program by using its name. It mainly used to achieve modular programming. We have seen the modular programming in C language. Okay, why we are using modular programming? To reduce the reusability of code. Once we have written a code, we don't want to reuse again and again. So we are using the modular programming. The concept of modular programming, we are define a function and same function whenever we need to call, then simply we can specify the function name. These things is specified in modular programming, isn't it? We have just like some int sum in C language, int sum. Then we can write, we specify int a is equal to 2, int b is equal to 3, like this. Then c is equal to a plus b. Then print c. Okay. Then whenever we need such block of code, we simply call this sum open and close bracket. Okay, this is called the function definition, and here we simply call the function. Okay, in the same way we are using macros. Okay, it is mainly used to achieve the modular programming. Okay, so same set of instruction can be used multiple times. It means we can reuse the same set of instruction. We do not need to write again the same instruction. We simply reuse the instruction whenever required by the help of macros. Simply we can repeat the same instruction with the help of macros wherever macros identifier is used. Okay, here what we have done here, simply we are defining a function int sum. Here is the function definition. Then somewhere in program we need to call it, just simply write the function name. But in case of macro we are writing the macros identifier. It replaces the actual definition instruction during the compilation. Okay, it replaces the actual definite instruction during the compilation, thereby no calling or and return occurs. There is no need of calling. Okay, it directly replaces the actual definite instructions. Here is the syntax of macros. Here is the macro name and number of parameter we are passing. Then here is the macro body and end of macro. So this is all about assembly language statements. Thank you for watching.